Okay, class, today we're going to talk about absolute value equations and inequalities is our next lesson, but today we're specifically going to talk about equations, solving absolute value equations. That's where you have the absolute value bars involved in your solving of an equation. I have this broken down for you in steps. Step 1 is to isolate the term with the absolute value. You have to get the expression that has just the absolute value by itself. And then you break into two different equations. I'll show you how to do that. And then you solve each of the equations. And then you're going to have two answers separated by the word or. Alright, so let's look at a couple of examples here. Example 1, absolute value of x plus 5 equals 11. Okay, so we have to isolate the absolute value of x. So that's what we're going to do first. Okay, so first we're going to take this absolute value of x, we want it by itself, so we're going to actually subtract 5 from both sides. Okay, we're going to subtract 5 from both sides. So then we get the absolute value of x equals, and then 11 minus 5 is 6. So you get the absolute value of x equals 6. That's step 1, is to isolate that absolute value. Now we want to set up two equations. When you have an absolute value, what's inside the absolute value could either be positive or negative, but then in the end your answer is positive. So this absolute value of x could be, what's inside could equal 6 or negative 6. So our answer then, we're going to break it into two things. X equals 6, but then x can also equal negative 6. So we have two answers. We have 6 or negative 6. I forgot to put the word or in there, but it is an or. Okay, so x can either be x can either be 6 or negative 6, because what's inside the absolute value, your answer is 6, but what's inside the x could actually be negative 6, because the absolute value of negative 6 is also 6. So both of these answers make this equation true. All right, let's look at letter B. Now again, our absolute value is not isolated, so we have 3 times the absolute value of n equals 15. So we have to get rid of this 3. We need to isolate the absolute value of n. So we're going to divide both sides of this equation by 3. Okay, and we're going to get the absolute value of n equals, and then 15 divided by 3, you're going to get 5. And then again, what's inside that absolute value could equal positive 5 or negative 5. So you want to go ahead and change that to where you get n equals 5 or n equals negative 5. So those are two possible answers on this equation. Both of these answers will make the statement true. So that's how you have to do absolute value equations. And the next couple that we're going to look at, we already have the absolute value isolated, but we just have to set up two different equations. So looking at letter C, alright, so looking at letter C, let me get down there here. Okay, we have the absolute value of 2p plus 5 equals 11. Alright, so our absolute value is already isolated. So up here, back up here, we had on step 1, isolate the term with the absolute value. We don't have to do that on these because it's already that way. So we're going to break it into two equations. So they won't be quite as easy as these others right away. Okay, so we need to go ahead and what's inside this absolute value, 2p plus 5, could equal 11, but it could also equal, what's inside could also equal negative 11, because if it equals negative 11, your answer is still 11. So we set it up like this. We get 2p plus 5 equals 11, okay? Or you have another equation that says 2p plus 5 equals negative 11. Oops, sorry about that. Let me fix that real quick. Okay, so that should be negative 11. So now we have two equations to solve. Let's start with the one on the left. To get 2p by itself, we subtract 5 from both sides of the equation. All right, so we bring down our 2p. So we get 2p equals, and then 11 minus 5 is 6. So 2p equals 6. Then we divide both sides by 2. So p can equal 3. That's one of the answers. Now we solve the other side. Okay, on the other side we're going to again subtract 5 from both sides. Okay, we're going to bring down our 2p equals, and then negative 11 minus 5, that's going to give us negative 16. So we'll go ahead and put our negative 16 here. And then to get p by itself, we divide both sides by 2. And then this time, so we write or, because or p could also be, oops, I wrote p as I was saying p. I should say or. Okay, so or, and then p equals negative 16 divided by 2, we get negative 8. So p could also equal negative 8. Both of those answers will show this problem correct. Okay, so p could equal be 3 or negative 8. And you could test these right back up here. You can plug those numbers in for p, and you will see that you will get a true statement. All right, so let's look at the next example here. All right, we have 5.5 equals t plus 2. Now, I know some of you like to have the variable on the left. You can go ahead and do that. We can go ahead and say t plus 2 equals, and then it's going to equal a positive 5.5, but it can also equal a negative 5.5. So then we also do t plus 2 equals negative 5.5. Okay, so then we have two equations to solve. On the left, we're going to subtract 2 from both sides. 5.5 minus 2 is going to give us 3.5. So t could be 3.5. Or, on the other side, if we subtract 2 from both sides, we get t could equal negative 7.5. So both of those answers will make this statement true. And that is how you solve an absolute value equation. At the next lesson, we will talk about how to solve an absolute value inequality. Thank you for listening.